Section 2 of Chapter 2 starts with what I just love. We're starting to solve, and I love it, love it, love it. Okay, the addition property of equality. Honestly, you should have learned this in Algebra 1. This should be a really, really quick, easy lesson. So we'll run through it pretty quick. Your definition for today is linear equation. A linear equation is any equation where all the variables have an exponent of 1. So you can have however many variables you have, how many different letters, as long as the exponents on all of those letters is just 1. No squared, no cubed, no fourth power, any of that type of thing. So the first section in your assignment is simply recognizing, are these linear equations? So the first one I have here is 3x minus 4 equals 11. So all you have to do to determine is this a linear equation is look to see, are all the variables, are the exponents 1? So x is my only exponent, and yes, the exponent is 1. So yes, this is linear. All right, so linear. Okay, what about this one? 5m plus 4 equals n squared. Well, I've got an m, and that just has an exponent of 1, but I have an n squared. So this one is not linear. It's that simple. Easy sneezy. So what we're going to be dealing with today is we're going to solve linear equations with one variable. And that simply means that you're only going to have one unknown, one variable, one x, one y, one letter that you're solving for. And what we're going to do is, hopefully you remember, when you're dealing with an equation, that equation says that the things on both sides of that equation are balanced. They're equal. They're the same. So if you put them on a balanced scale, it comes out even. So you can do whatever you want to that equation, to that scale, as long as you do, I love this, the same thing to both sides. All right? As long as you do the same thing to both sides, you can do whatever you want to that equation. So in this case, I'm looking to see, x has got an extra negative 13 here. So if I add a 13 onto this, that 13 goes away. And I can do that as long as I do the same thing to both sides. So if I add 13 to this side, now all of a sudden on this side I have x, and on this side I have negative 9. Yes. So x equals negative 19 is my solution. And we learned yesterday that we can, or in section 1, that anytime we want to check your answer, just put the negative 9 in. Negative 9 minus 13. Yep, negative 9 minus 13. 9 and 13 are both 22, and they're both negative, so negative 22. There you go. Now, sometimes it's not that quick and easy. Sometimes you have to simplify things a little bit first before you can solve. And if you know how to do this, pause the tape or pause the video and the tape. Wow. Pause the video and then come back and do it with me. All right. So if you're back, hopefully you got the right answer. And if you don't know how to do it, then here we go. Let's do it together. So here you are supposed to do what's inside these parentheses first, but because it has an n, you can't. So in this case, you must distribute. And we learned how to do that earlier. So we're going to distribute that through to get 6n minus 18. Don't forget, when you distribute, that means you don't just bring the negative 3 down. You've got to multiply everything inside those parentheses. This is not inside a parentheses, so it just stays 5n. And these are just simply negative 25 plus 4. And in this case, because it's the only thing on that side of the equal sign, in this step, you could go ahead and just combine that. So negative 25 plus 4, because one is positive and one is negative, you're going to subtract. And because the 25 is bigger, your answer is going to be negative. So 25 minus 4 is 21. So now, simplifying a little bit further, you need to put together any like terms. So we've got in here and in here. So 6n minus 5n, oh, that's just n. n minus 18 equals negative 21. So now I can see, oh, the n just needs if we add an 18 to this side, that goes away and all I have left here is n, which is what I want. I can do that as long as I do the same thing to both sides. So I have to add 18 to this side. 18, 90, 21 equals 3 because the signs are different. So I subtract. 21 minus 18 is 3. The 21 is bigger and it's negative. So my answer is a negative 3. You can do the same thing if you have a variable on either side of the equation. Did you get all of that? If you didn't, you'll have to pause because I'm erasing it. So our next equation looks like this. 5x minus 8 equals 4x minus 3. So remember, you can do whatever you want as long as you do the same thing to both sides. So I've got an x on both sides of the equal sign. Make sure if you want to put those together, you've got to subtract one of them to bring it to the other side. So let's subtract the 4x. So 5x minus 4x gives you just 1x. Don't lose the rest of your equation. And so now it's just a simple equation to solve. You're going to add 8 to both sides. That one drops out, and so x is just 5. Now, what happens, you might say, how do you know which direction to move that? What if we had 5x minus 8 equals 4x minus 3, and I had said, well, what if I had moved this 5x to that side? Now I have negative 8 equals a negative x minus 3. Well, now I add 3 to both sides, and so negative 5 equals a negative x. So now x equals just 5. If both of them are negative, I can divide both by a negative 1 and make them both positive, and so x equals 5. We get the same answer. So it doesn't matter. Don't worry about, oh no, I moved mine to the other side, and it doesn't matter. As long as you do the same thing to both sides, I would suggest that you move the smaller number to keep your variable positive. You don't have to, but it just saves you a step later. So if you've got one smaller and one larger, I would move the one. I would try to keep it positive if you can. All right, let's do a couple more. I would like for you to do one with a few steps. So 7n minus n minus 3 equals 4 times n plus 4 plus n. All right, pause it and come back and do that with me. Okay, hopefully you have a solution up here. Let's do it. So 7n stays 7n. This is a negative 1, all right? So negative 1 goes through the entire parentheses. Don't forget that. So now that becomes negative n, and because this was a negative 3, now it's a positive 3. That's where a lot of people mess up. Don't lose those negatives. Make sure it goes all the way throughout the whole parentheses. Now this 4 has to be multiplied by everything in these parentheses, so 4n plus 16, and this doesn't have to be multiplied because it's not. Haha. All right, combine what you've got. 7n minus 1 is 6n plus 3 on this side equals 4n. Let's add these two together. 4 and 1 more is 5n. Remember, if you don't see anything in front of that variable, it's a 1. So we've got 5n plus 16. We've got a 6n and a 5n. I want to keep it positive, so I'm going to subtract from this side. So now n plus 3 equals 16. Subtract 3 from both sides. So now n equals 13. Is that what you got? I hope so. Let's do another one. Here we go. No rest for the weary. Same thing. Here we go. 5 times 2. Oh, you should pause it and try to do it yourself. All right. 10t plus 5 minus 8. The 4t is on its own. Minus 3 times 1 is negative 3. And negative 3 times a negative 2 is a positive 6t. Combining like terms, so this still stays a 10t. And positive 5 and negative 8 is a negative 3. Because they're different signs, so you subtract, and the 8 is bigger, so it's negative, equals a 4t plus a 6t, or 10t, minus 3. And now if you'll look at this, you can see, well, wait a minute. 10t plus minus 3 is the same as 10t minus 3. So if I subtract 10t from one side, it subtracts it from both sides. And then I end up getting negative 3 equals negative 3. If you end up with an equation where the two sides are equal, that's called an identity. And what happens in an identity is no matter what number you put in for that variable, your equation is going to be true. So if you come up with an equation and you work it down to the end and you've got a true statement, but you don't have x equal to something, or in this case, t equal to something, if it's a true statement, it is an identity, and your answer is all real numbers. So any real number you put into this equation is going to make that equation a true statement. All right, one more type real quick. Hang in there. We're almost done. This is a fast one. Once again, I hope you got that. Otherwise, you can back up and make sure you got it all down. Last one. 4x minus 3 times x plus 5 equals 2 times 2x minus 3 minus 3 times the quantity x plus 5. Woo! Can we do it? Yes, we can. All right. So the 4x is by itself, so it stays by itself there. Negative 3 times x is minus 3x. Negative 3 times the 5, don't lose the negative, minus 15. Oh, you should have done this on your own and then come back. Pause it and finish it up and then come back. Equals 2 times 2x is 4x. 2 times a negative 3 is negative 6. Negative 3 times x is negative 3x. Negative 3 times a positive 5 is negative 15. Now we just combine like terms. There's the x's. You can't combine them across the equal sign. Don't forget that. You can only combine what's on one side of the equal sign. So 4x minus 3x is just x minus 15 equals, be careful with your signs. This is a 4x and a negative 3. So 4x minus 3x is x. And negative 6 and negative 15, 22, no, 21. Minus 21. Yes. Ha. So subtract your x. Oh, wait a minute. Negative 15 equals negative 21. It's kind of like what we just did, but negative 15 is not equal to negative 21. This type of problem, if you work it, and you get down to where you've got an untrue statement, that means that no matter what you put in for that variable, it's never going to come out true. So this is a contradiction. And a contradiction has no real number solution. So there is no solution. There is no real number that's going to make that a true statement. So it's a contradiction. There's no solution. So your answer on that would just be no solution, no real numbers. All right. So this is just a lot and a lot and a lot of solving. So there you go. Have fun.